Hello. Today we will be discussing the method of calculating an electric charge of a charged object, and more specifically, how to improve this measurement. I will begin by giving an overview of the specific problem we studied and the results we found, followed by the fundamental principles used to find these answers. Next, I will describe the calculations, code fragments, and model used to exemplify the problem. And finally, I will end by analyzing the results and what factors ensure that the answer found is reasonable. Beginning with the introduction. The goal of this experiment was first to estimate the charge of a charged tape, known as a U-tape, caused by another U-tape, by using the electric and gravitational force formulas, and then to make this value a more accurate estimate of the electric charge between the two charged tapes. Now we do this by finding the distance between the two tapes and dividing the first tape into multiple portions and treating each piece as a point charge to find the electric force from the second tape on each piece of the first tape. After completing these steps, the value of the charge found was 2.02 times 10 to the negative fifth coulombs, which, when compared to the value of the charge found in Lab 1, which was 2.1 times 10 to the negative eighth coulombs, where we treated the entire tape as a point charge, is more accurate as it is the result of the sum of multiple point charges, in this case 16. As you can see, I have included a rough diagram which shows a rectangle which symbolizes a length of tape that has been divided into 16 pieces, each of which represents a point charge and is included in the sum of the total electric force. I chose the number 16 arbitrarily as it was a value that demonstrated a significant difference from the initial experiment in which the entire tape was treated as a point charge. Now, the reason that the aforementioned formulas are vital for solving for the charge is the momentum principle, which states that in an isolated system, momentum is conserved. This principle is proven by Newton's third law, which states that for every action, there is an equal and opposite reaction. Therefore, when a collision occurs, the momentum prior to the collision is equal to the momentum after the collision. This is applicable to our experiment as it highlights the fact that there are two equal and opposite forces acting on our tape, gravitational and electric. Additionally, the reason that our experiment is more accurate when we include multiple point charges instead of just the one point charge is the result of simple calculus, as shown here. The sum of an infinite series is equivalent to taking the limit as the series goes to infinity, which becomes more accurate as it gets closer and closer to that value of infinity. For the same reason, the more pieces we divide our tape into, the more accurate our charge estimate becomes. Now going into the data portion of the lab. From the initial measurements, we get that our estimated net charge on the tape is 1.96 times 10 to the negative eighth coulombs, which we calculate from setting the gravitational force and electric force formulas equal to each other, giving us mg equals kq squared over d squared and solving for q. The code, while probably the most difficult portion of this lab, functions as a medium for us to demonstrate our findings. As you can see, for loops are particularly useful in this lab as they allow us to calculate the total electric force on individual pieces of the first tape and keep track of this information by summing it up into one variable. Each iteration of the for loop represents us calculating the charge on one individual portion of the tape, so that once the loop is complete, we find the total electric force due to all the pieces that the tape has been divided into. Now, as you can see in the model here, the red and blue spheres represent the tapes, and the green arrows represent the electric forces on each of the 16 pieces of the tape. You may notice that the arrows have a slight angle as they are tilting outwards, a point which will become relevant in a moment when I discuss the reasonability of the results. Additionally, you can see that the model returned a charge value of 2.2 times 10 to the negative fifth coulombs, which is less than our value in Lab 1. Sorry, greater than our value in Lab 1. Going into the conclusion. As I mentioned, the charge found in this lab had a larger value than the one found in the first lab, which is due to the angle of the arrows that I just brought up. Because the arrows, particularly those towards the end, now have a relevant x component, the magnitude of their y component has decreased. If the charge had stayed the same, the electric force and gravitational force would become unequal. Thus, in order to ensure equivalence of these two forces, the charge increased in value, showing that our results are reasonable and in accordance with the laws of physics. That's it for Lab 2. Thanks for watching.